Hey folks, how's it going? It's been a while since I've done one of these. Um, I'm going to go over some structural stuff that I've done to my house, and hopefully this is a benefit to anybody who runs into some scary stuff when they're doing renovations on their house. So we're going to flip this around. A couple things to show you. That is my mess there. These floors were just redone. It's going to come up because the whole house is kind of a mess and destroyed. These are my members, and as we go, so basically, I ran into this bathroom, and this was our project, and that is a structural support, which you'll understand why. And we started tearing this down. The house is 120 years old. It's this is floors my wife is working on. The house is 120 years old. It is built in 1899. It is all kinds of scary. So we had this bathroom, and it's super crappy, or it was. And they had tubs. Like there was a giant gap over here in the wall. It also used to be a dungeon. We added a window. Well, we didn't add a window. We found when we started tearing down the walls in here, we found that they had boarded up an entire window. So we bought a new one to bring some actual daylight in here, and we're changing everything out to PEX. That's a PVC line for electrical. Actually, have that in there. But what ended up happening here is this whole project ended up just getting delayed because when we opened up the floor, we found these kinds of terrifying things. Like that seems to be missing a structural member, and over here there's a missing structural member. Right? See the dark brown wood. That is an actual 2x4 back when they were, or 2x8, back when they were 2 inches by 8 inches. Modern stuff is nominal, so it's not quite. If you notice, it just disappears. So the tub used to run from this all the way out here on a completely non-structurally supported member. In addition, that corner right there, you can see these things that are running down the hallway. That is a structural supporting wall. That is a structural supporting wall. That has no support. This is cantilevered out, which is, it's terrifying. So I was expecting, I was not expecting craziness when I ripped up the floor, and they just destroyed this. So the house has had, as far as I can tell, 3 major bathroom renovations. Obviously, one would be the introduction of plumbing back in the day, when they first did that, the introduction of electricity, and the stuff that we had a cast iron pipe that went down there, and there was, if you see this little line right here, my finger's kind of tracing it. I'm actually very pleased with this. This little line was originally a lead pipe that connected up there that I had to pull out because they left it there, which was one of the reasons when you actually sit there and see it, they could actually bend and form these pipes to the drain area. Whereas when you take a look at these cross hatches, this is PVC, right? And that was PVC that I have now removed. What makes this terrifying, though, is the lack of structural support. There are 5 structural members here. There's 1, 2, 3, 4, and 5. And they cut out 2 of them. 2 of them. And then on top of that, you come down here, of the remaining 3 structural members, here's 1. You can start seeing how deep they notched this board. And ultimately, when we start talking about notching boards, right, your structural member is only as good as the height of the member. And they did some other stuff too, like they tried to reinforce that one by laying a 2x4 lengthwise. I mean, that's just dumb. But when we start talking about the math associated with your floors, this is done with moments of inertia. And ultimately, the moment of inertia is roughly the... let's see if we can show you guys. So if we are sitting there and we're taking a look at this end of this 2x4, right? The height of the 2x4 is squared and the width adds together. So if I want to sit there and I want to double the strength of something, I can go like this. But if I was to sit there and instead double it by adding a second 2x4 down here, I would actually be giving the structural strength of the member a 4-fold increase in capability. So you always want to be seeing these vertical lines. That's why people build with I-beams and various other things. You get a square impact to the fibers of the structural support. So when you notch these things, which is not what you're supposed to do, when you notch them, and I understand they wouldn't have had some of the more complex power tools that I have in here. That's not one of them. I have not used that yet. I was just trying to fit in some of these spaces here. But when you notch these boards, you actually reduce the structure to this minimum thickness, right? And it is a square value reduction. So if they notch the board, and some of these are notched all the way down to, I think this one's notched down to like 2 or 3 inches from the bottom. That means that they took something that has, say, a strength value of 64, and if they notched it down to 3 inches, that would 8 inches goes 8 inches squared is 64. If they notched it down to 3, that brings 64 down to a factor of 9 for support. You've reduced your structural loading capability of that member by like a factor of 1/6. That's insane. Now, the problem that we have is, and oh, by the way, again, they laid the tub this way. So they actually put the highest mass load in the least structurally sound area of the thing. I have no idea how I didn't fall through while taking a bath in the early first few years of this house. Like this truly terrified me. When I dislocated my elbow, it was a great, wonderful excuse to not be up here. When you come in here as an engineer and you start looking at these things, like, it made me whimper. I fell through that, by the way. Drywall does not support your weight. It's not that I thought drywall supported my weight. It's that I was operating on like a 2 foot by 2 foot square here, and I was trying to actually secure this member. This is the first one that I worked on. And I'd overextended trying to drill in, and I was trying to push myself back, and I just fell off and fell through. So that's why there's a gap down to the first floor. Yeah, it's a wonderful, lovely gap. But what I'm also doing is I'm changing up the way this whole bathroom is laid out. So I want to run pipe all the way over here. The tub is going to be over in this section, so it's actually going to be less cantilevered out. The tub is the heaviest thing that you're going to have. It's like 1,000-ish pounds when you're loaded with a person plus water. So most of that's actually going to be as close to this wall as possible. And this should be roughly where the drain comes out. And then I'm going to have another length of pipe coming out here, and this will be where the toilet is. And that allows me to put a vanity right about there. So I'm hoping to get about a 24-inch vanity is what the calcs come out to be, is what I can fit in that spot, because we gain like 6 inches in that direction and 6 inches from that direction from taking down the plaster and lath, the plywood that they put over that, and then the surfacing materials that they put over that, which is, it was just like this weird cardboard crap. But what you want to do if you're going to try to repair a joist, which was what I came up here to talk about, is you want to sister the member. And there is I probably should put another piece in there. I'm not so sure I want to. The only reason that this only has one support right now is because I wanted to mount it to that post and that floor. That is the key member right there. And B, because I need some room to work with over here to attach the fixture for the tub and attach the fixture for the toilet. That won't be as big of a deal. I can probably maneuver those things around. I'm gonna have to take a look at some elbows and fittings and see what I can get. But what you're gonna want to do is you want to sister these joists. And this is a much better example over here. Now you can see that I have 2 boards running a very significant length of this one, which is destroyed. And I'm doing the same thing here. I chopped that one out. This is my doing. That's why there's a structural support down below. I couldn't physically get tools in to do my 3.5-inch diameter hole saw, which is what you need for a 3-inch pipe, which is what you're going to use for like one toilet fixture, essentially. So. But what you're going to want to do is you're going to want to put a board on either side of the other board, and you want it to run as long of the length of the board as you can, especially to kind of bypass the weakened points. So those notches are all weakened points, and where I actually drilled the hole is a weakened point too, but which is why I have this secondary support right there, right? So that is running to that position right there, and the pipe should be able to go through, but. By avoiding notching, I can actually keep this much more structurally sound. Now, a lot of this, over here, is probably overkill. Probably going to maybe put in another structural member there. Probably going to put in another structural member there because based on my drain heights and whatnot. This might be a little bit of overkill, but I'd rather be over the top on these things than cutting my boards, cutting out 2 structural supports and whatnot. And this right here, this is going to also be sistered all the way back over here, where there's going to be a board on each side. A hole will be drilled through that, and I'm going to be filling that because these are actual 2x4s or 2x8s instead of nominal. It requires about a 1-inch-ish thick nominal board plus a 2-inch thick nominal board. And then the 2 nominal boards on each side, and that will also have a hole and a run. But now, that's how you can repair a floor. And the key point that I really wanted to go into was, do not notch your boards. It significantly weakens your floor. Do not turn around and think that you have structurally secured something by laying 2x4s flat. If they'd put them vertical, I would actually I would have a little bit more respect for the job that was done. I'm not saying it would have been good. I still would have been crying at the fact that they tried to like structurally support that to that with that. Like it's going to be yanking out from the wall when it pulls down, and you should still be like, you really want to have direct load directly on top of these things. You don't want to be cantilevering stuff out. So again, this is cantilevered out, which means that there is not a support on this end. So all of the structural integrity comes from like this area over here. This is free swinging in the breeze. So you don't want to be cantilevering stuff out, which is what they tried to do here for structural reinforcement. They should have just run another beam, cut a hole through it. I'm sure that there have been hole saws in existence for a significant period of time. But the key things that I wanted to have you guys walk away with is, 1, do not notch your boards. That does much more damage than putting a hole through them. 2, if you want to repair damaged boards, like when you rip up a floor and you're working on a bathroom and you find something terrifying like this that you're questioning how it is that you managed to live this long, you're going to want to sister these joists. And I'm sistering every single one because every single one has been notched or cut or damaged or destroyed or just severed entirely. So I'm repairing every single one of these joists. And I would probably actually replace them, but that would require a lot more effort. It would be interesting to put in like 2x10s, but then it wouldn't match up with that floor. So I kind of got to stick to the 2x8s. So 1, vertical placement. Make sure your things go up and down because that is a square for your moment of inertia calculations, as opposed to horizontally, right? So if I what just happened? Phone is freaking out. I do apologize, people. What you really want is if I'm going like this, each of these fingers is adding an extra finger worth of strength. If I go like this, these are squaring that finger's worth of strength. So I'm going from 1 finger to 4 fingers. I'm actually increasing my load-bearing capacity by a factor of 16, whereas if I go from 1 to 4 fingers like this, I'm only increasing it to a factor of 4. And that is how you repair things. So keep that in mind when you start making cuts, when you start making modifications. Yes, I know that there's all kinds of things that you can do, but it is better to do it the right way and not die than to do it the wrong way and terrify people in the future. But in any case, you guys have a good day. I've got some more work to do, and I will see you later.